Almost every single motorsport discipline is an exercise in engineering a machine to operate against strict physical boundaries. In Formula One, teams optimize for extreme agility and rapid acceleration, confined to the parameters of short 300-kilometer sprint races. Endurance racing demands the exact opposite. Engineers prioritize thermal efficiency and component survival, ensuring the vehicle can withstand 6,000 kilometers of punishment over 24 hours. But there is a third environment, one eliminating the need for braking zones and corners entirely, replacing them with a flat, isolated expanse of salt. Circuit racers must compromise. They balance downforce against drag and cornering speed against tire wear. A land speed vehicle strips away all conflicting demands to solve a single problem: the localized discharge of absolute, uncompromised energy in a straight line. The Venturi VBB-3 was built to test the extreme limits of electric thrust. On the Bonneville Salt Flats in 2016, its dual electric motors pushed it to a peak physical speed of 358 miles per hour. Yet its official, recognized world record is locked at 341.4 miles per hour. A 16-mile-per-hour discrepancy exists because top speed is not a matter of what a car can physically achieve on a single run. It is governed by a punishing international regulatory framework known as FIA Appendix D. An official world record does not measure peak physical capability. It is a rigidly defined mathematical construct that must survive layers of precise bureaucratic and engineering scrutiny. Before a vehicle even rolls onto the salt, it must be strictly classified under Article D2 of the rulebook to establish parity among competitors. This chart shows categorization rules. Category A defines automobiles completely divorced from series production, custom-built machines answering exclusively to the physics of top speed. Looking at engine types, this matrix places the VBB-3 exactly into Group 8th, designated for electrical engines powered purely by electricity. This table details the allowed weight classes. Unlike Formula One, which strictly limits minimum mass to ensure agility, Category A accommodates extreme weight, with Class 11 allowing for vehicles exceeding 5,000 kilograms. Because weight is unrestricted, Venturi's engineers equipped the VBB-3 with a pair of 1,500 horsepower electric motors and a massive 1.6-ton lithium iron phosphate battery. This pushes the total vehicle weight to 3.5 tons. At 300 miles per hour, generating aerodynamic downforce creates too much drag. Instead, engineers use the battery's immense gravitational mass to force the tires into the salt and convert torque into raw tractive force. In this arena, mass is a critical engineering tool to anchor extreme thrust to the earth. Once a car approaches 550 kilometers per hour, the atmosphere transitions from a fluid into a solid physical barrier. FIA Article D1.1.5 requires engineering teams to submit mathematical proof of aerodynamic stability in yaw before the car is ever allowed to run. The math hinges on a critical physical relationship: the distance between the vehicle's center of gravity, its mass, and its center of pressure, the exact point where wind forces act on the bodywork. If the center of pressure moves ahead of the center of gravity, the vehicle acts like a reversed pendulum. A slight crosswind will catch the nose and cause the car to violently spin out. Engineers designed the bodywork to keep the center of pressure strictly behind the center of gravity. Now that same crosswind pushes the tail back into line, using the air itself to auto-correct the steering. Circuit racing uses wings to press a car down into a track. Land speed engineering abandons that entirely, shaping a self-correcting aerodynamic dart. Inside this 3.5-ton missile sits a fragile biological component. Under Article D11, the FIA scrutineer must verify that the driver can survive a catastrophic failure before the electric motors are powered on. This begins with a highly rigorous safety protocol specifically outlined in Article D11.3.2 of the rulebook, the blindfolded cockpit orientation test. Wearing full safety gear, the driver must rely on pure muscle memory to locate fire actuators, fuel shutoffs, and parachute levers in the dark. Following this, Article D11.3.3 demands that the driver, bound by a multi-layer SFI standard fire suit, unlatch the safety harness, and escape the sealed canopy completely unassisted in under 15 seconds. The vehicle is treated as a highly volatile environment. The driver must be biologically programmed to escape it. The record attempt itself takes place on a vast, temporary open course, exactly like the environment of the Bonneville Salt Flats. Before any run, surveyors verify that the course does not exceed a 1% gradient over any 100-meter section. You cannot use gravity to achieve top speed. This brings us back to the VBB-3's 358-mile-per-hour run. A single directional pass is inherently corrupted by imperceptible slopes and favorable tailwinds. Article D13.2.3 neutralizes these advantages with the 60-minute bidirectional rule. The vehicle must make an outbound run, come to a complete stop, and run back through the same trap in the opposite direction, all within exactly 1 hour. For an electric vehicle, this creates a severe engineering crisis. The team must manage the massive thermal overload of a 2-megawatt battery discharge without the luxury of time to let the system cool down between passes. An absolute speed record is a brutal, localized endurance test. It is a battle of thermal management squeezed into a merciless 1-hour window. The final regulatory hurdle is recording the precise speed of the vehicle as it crosses the surveyed trap. Human intervention is strictly forbidden. No official is allowed to press a stopwatch or interpret a time. Articles D13.1.2 and D13.1.3 dictate the use of redundant, parallel, automatic timing systems that log the data directly to non-volatile memory. Article D13.3.2 enforces mathematical severity. The mean time must be calculated exactly to the 1,000th of a second. The FIA dictates that the resulting calculation cannot be rounded up or modified in any way to gain an advantage. The VBB-3 achieved a peak of 358 miles per hour in one direction, but its official, recognized record of 341.4 miles per hour is the strict, unrounded mathematical average of its 2 grueling passes. A land speed record relies on both brute force and extreme bureaucratic precision. It is a highly formalized scientific experiment, engineered to exploit the absolute limits of earthbound physics.